Hello guys, welcome again to another video. So in this video we are going to start learning about integration. Now in the previous videos we had learned about how to do differentiation, how to use the chain rule, and how to do different kind of operations on chain rule and different derivatives and so many other stuffs, right? So this is our final step so that we can start learning some of the main fundamentals in integration, which will help us in order to find all the necessary tools to complete and learn continuous random variables. So integration would be divided into a lot of parts, and we will try to cover the basics, but remember your basics from differentiation first. So I would just write it down in a table, and after that I will try to explain all of this to you. So in this table what I'm trying to do is write a function on the left hand side and an integral on the right hand side. So note that in the first two entries, the function x to the power n when differentiated will always give you n into x to the power n minus 1 for all of the n's. But for integration of x to the power n, what it will give is x to the power n plus 1 divided by n plus 1. So as you know, in derivative the exponent comes down as a coefficient and then the exponent is reduced by 1. So the opposite happens in integration. The exponent is increased by 1 and then whatever the increased exponent is, that is divided. So that's integration. And as you can see in the second case, x to the power minus 1, that has a derivative of minus 1 upon x square, and the integral is log of x. That is why it's a special function. So remember that 1 by x when integrated will always give you log of x, because if you remember, the derivative of log of x is just x to the power minus 1, and integral is basically the opposite of derivative. So whatever you see in the integral column, if you differentiate that, you will get back the function. So like these are the basic derivatives that we need to know now, and integrals which we should start off. But what I need to focus here is that in integration it's not actually as simple as it was in derivative. By using some rule or something, we can always evaluate, right? So derivative of a function can almost always be evaluated if the function is composed of only elementary terms, because we do know the derivative of all the elementary terms, right? But in case of integration, it may also be possible that for a given function there is no such integrand in terms of elementary functions. So an elementary function may not always give you answer, right? So this could happen. So let us begin our journey and let us know some of the basic rules. Integral of a function f of x is written as, so we will denote by capital I an integral, and the integral of function fx, obviously the variable is x, will be denoted by fx into dx. So this dx term is something which we have used, you have seen in derivative where we use the term d of dx, d by dx. So here we rather multiply with dx. Dx is called an infinitesimally small element of x, and this helps you to integrate. So this is something which should always be present in an integral, and thus the integral sign makes sense, right? So if we were to integrate, suppose x dx, then we would only focus on the function x because dx is always present by far, and as you know, this comes in the category of the first kind of functions where x to the power n and n is not equals to -1. So the answer would just be, since the power is 1 here, the answer would be x to the power 1 plus 1 by 1 plus 1 plus c. So whenever doing an indefinite integration, now indefinite integration is something where you do not have limits, see. So when you do a definite integral, you will have some numbers or some functions as limits, as a lower limit and as upper limit, because you always integrate up from in some interval, okay, and you write the endpoints of the interval here. But when you are doing indefinite integration, we always add a plus constant c, because when you differentiate this thing back, you should get the function, right, which you will get, but it's not entirely sure that only this function would give you, because any constant, even if was added when on derivative, will become 0 and will give you the same function. So for any constant c, this equation becomes true. So since we do not exactly know what the constant was, so we just put a plus c. So this answer would be just x square by 2 plus c. Imagine that x square by 2 plus 5 or x square by 2 plus 2, both of them would give you on differentiation the value of x, right? Similarly, if you were to do 1 by x dx, the answer would just be ln of x plus c, right? Okay, so we do know about these basic differentiations, and let me now iterate some of the facts. Integration of f of x plus g of x dx. So when there are two functions added, we can obviously write them as integration of, it's actually plus minus, even for minus it works, integration of fx dx plus minus integration of g of x dx, okay. If there is any constant c such that you have c into f of x dx, where c is independent of x, is just a constant. When I say constant, I mean it is independent of the integral variable. It will just give you c into integral of fx dx, right? So these are the two things we shall remember. There is not a hard fast rule for integrating product of two functions or division of two functions, but what we do have is something we will learn in the later chapters, which we call integration by parts, which is not really a rule which will readily integrate anything for you, but yes, it does help you integrate a lot of functions. So how do we actually integrate? So there are some ways to do that, and we will learn those methods slowly, one by one. So let us integrate some of the basic integrals first. Let me write down the integrals. So let us try to evaluate all three of them. The solution for 1, as you can see, it's just e to the power 2x dx. What we can do here is we can write e to the power 2x dx equals to e to the power 2x divided by 2 plus c, right? Similarly, for number 2, what we can do is we can write integration of sine of x plus cos of x dx, and we can write integration of sine x dx plus integration of cos x dx, as I already mentioned that we can separate the two functions which are in addition or subtraction form and integrate them separately. Okay, so as we have learned, the integration of sin x would be just minus cos x dx, there is no dx because it is out of the integration, plus integration of cos x is just sin x. And you might wonder that there should be two constants corresponding to both of them, but we do not really care because since they are constants we can just write a plus c at the end of the whole integration, because it doesn't really matter because c is unknown, right? So whatever c1 here and c2 here plus would give, probably capital C would also give you the same result. If you even if you write two constants, it can be absorbed into one, right? So this is the answer for second one. And for the third one, it's right, e to the power log x plus x dx. But we observe that e to the power log e of x, which is the natural logarithm, is just x. So x plus x dx, which is basically 2x dx, and we can see that the constant 2 comes out and it's just x dx, and x dx has a form which is x squared by 2, and there would be a plus c outside. This would mean you will have the integral as x squared plus c. This is your answer. So these are just the basic applications of the direct formulas. So this is not at all integration, it's rather like we are trying to revise some of these formulas and some of these formulas from this table, right? But now let us come to the actual part of integration. So when integrating, obviously you are trying to find a function which when differentiated will give you back the integral, right? So if you're trying to integrate some fx dx and what you get in answer is a function g of x, what you actually mean is when you differentiate g of x, you should get back the function f of x, right? Or in other words, there exists a function gx such that g prime x should be equals to f of x dx. This also means that when you have an integral of a differentiation, that is if you have integral of f dash x dx, where f dash x is already the derivative of fx, it would just give you fx back. This is what integration means, because it's just the opposite of differentiation. Okay, so this is very important to understand, that obviously when you are trying to integrate a function, you are trying to find another function which when differentiated will give you back the integrand. Now let us go to some of the topics. Method 1, and by far the most important method, which we are going to learn extensively in this video and in future videos. Rule of substitution. Rule of substitution, right? So how do we find this? How do you find the rule of substitution? So consider an example. Let us say we are trying to evaluate the integral I equals to 2x e to the power x squared dx. Now this is not a part of any of the elementary functions that you have seen, but it's rather a composition of two. And e to the power x squared, remember that e to the power x's integral is e to the power x, but in case of differentiation of e to the power x squared, you could have just used the chain rule, right? But it's not so simple here in integration, because there is no definite rule for integrating e to the power x squared dx. Neither there is for integrating x into e to the power x squared dx, right? So we need to make our way out of it. So what we do is we try to see what is the anomaly here. So if it were e to the power x only, it would have worked, and if this x were somehow magically gone, so this x squared term needs to be substituted. How do we do that? So we just substitute it. So let us introduce a new variable which is y, and which equals to y equals to x squared, right? Now only y equals to x squared would not give you an answer, because you cannot just substitute it as y. That is why what we do here is we use d of y, we differentiate both sides to find dy by dx. So in differentiate y in terms of x to find 2x, but then take this dx to the other side to find dy equals to 2x dx, right? and then you can see that this integral is basically equals to dy into e to the power y, which is just e to the power y plus c, or e to the power x square plus c. So this is the way we will try to do all the problems, and from the next section forwards we will be doing a lot of problems in rules of substitution. This is just an introductory video. So I hope you like this video, and in the future sections we shall continue our investigation on integration. Meanwhile, please do check out the Breatter Maths app, which is a very lovely app which has all the notes and theories and video solutions regarding to all the math things I am teaching here. So do check it out. Thank you.